Today's lesson is on similarity in right triangles. Our objective is to find and use relationships in similar right triangles. Our essential understanding is when you draw the altitude to the hypotenuse of a right triangle, you form three pairs of similar right triangles. We're going to first cover geometric mean. The geometric mean is the product of two numbers and then taking the square root, which is basically a proportion of a over x is the same as x over b. So if I want the geometric mean of 6 and 15, it is 6 over x equals x over 15. Cross multiply, you have x squared equals 90. So x is equal to the square root of 90, which is the square root of 9 times the square root of 10. The square root of 9 is 3, so 3 square root 10 is the geometric mean of 6 and 15. Let's do another example. The geometric mean of 4 and 18. Geometric mean is basically the product of two numbers and then taking the square root. So I have 4 over x equals x over 18. Do the cross product. I have x squared equals, I have 4 times 18, 72. So x equals the square root of 72. So if I want to simplify this, this is the same as saying square root 36 times square root 2. So I have 6 square root 2 is the geometric mean of 4 and 18. So what the objective stated in the beginning of the lesson, if I have an altitude, so of a right triangle that goes to the hypotenuse, so C to D is an altitude because it goes from a vertex to the opposite side 90 degrees. So if you draw an altitude of a right triangle that goes from a vertex to the hypotenuse, you're going to create three similar right triangles. So you have your big right triangle ABC is similar to ACD, and it's also similar to CDB, and then you also have ADC and CDB similar. So again, you draw an altitude of a right triangle that goes to the hypotenuse, you will have three pairs of similar right triangles. So the objective will be to write a similarity statement given an altitude going to the hypotenuse of a right triangle. And I'm going to teach you how to write these similarity statements by drawing the three right triangles. So I have triangle 1, triangle 2, and then you also have the big triangle ZXY. So when you're doing these problems, I would highly suggest you redraw your three right triangles in the same direction. So I'm going to redraw my three right triangles all in the same direction. So here's triangle 1, triangle 2, and then here's the original. So I'm going to label my original triangle. So in my original triangle, I'm just going to say this is X, this is Z, and Y was my 90 degrees. Now for triangle 1, since I know that these triangles will be similar, okay, corresponding angles have to be in the same position. So for triangle 1, my 90-degree angle is W. Okay, if you notice in triangle 1, it has angle Z, which is also in the original. So angle Z has to be in the same position as the original triangle. So Z goes here. And then you have Y. For triangle 2, I know like the 90-degree angle is W. And in triangle 2, I have angle X. an angle x is also in the original triangle? Well, x in the original triangle is up top, so x has to be up top in triangle 2, and y goes the last vertex. Now I can write my similarity statement. So I have triangle x, y, z is similar to y, w, z, and it's similar to x, w, y. So what you want to do is redraw 3 right triangles, all facing the same direction. Label your 90-degree angles, and then find the common, or I should say find the overlapping angles that are in triangle 1 in the original, and the overlapping angle that is in triangle 2 in the original. We'll do another example. So I want a similarity statement from this original right triangle of QRP. So remember that S to P is an altitude. So if I go an altitude to the hypotenuse of a right triangle, it creates 3 similar right triangles. So I'm going to label my triangles 1 and 2, and I have the original. So I'm going to have my 3 right triangles. So I'll have all of my right triangles facing the same direction. Label my 90-degree angles. Well, in the original, I have Q, R, P. Okay, triangle 1, my 90-degree angle is S. In triangle 1, I have angle Q. Angle Q is also in the original. So here's my original. So Q goes up here. And then I have P. And I have triangle 2. Angle S is my 90 degrees. Triangle 2 has angle R. Angle R is also in the original. So R goes here. And P goes up there. So now I have my similarity statement of Q, P, R, similar to Q, S, P, and similar to triangle P, S, R. Now you can use these diagrams to help you solve for variables when you're dealing with algebra in similar right triangles. So I have similar right triangles. So I have x and y. Notice that I have a right triangle. I'll label A, B, C, and D. So ABC is a right triangle. I have an altitude of DC. The altitude goes to the hypotenuse. Therefore, I have 3 similar right triangles. So if I have 3 similar right triangles, I'm going to draw my 3 right triangles and construct my 90-degree angles. And here's the original. Here's triangle 1 and triangle 2. And remember, they're all similar. So if they're similar, they have the same ratios, and corresponding angles will be congruent. So in the original, I have A, B, C. Doesn't matter where I put A and B, as long as I know that C is my 90-degree angle. Triangle 1, my 90-degree angle is D. Triangle 1 has angle A, which is also in the original. So A goes up top, and C goes here. Triangle 2, I have D as my 90-degree angle. Triangle 2 has angle B, which is also in the original. So B has to correspond correctly. And C. So since I have all my 3 right triangles, I can now fill in the information given from the diagram. So I know that A to D is 4. So A to D is 4. I know A to B is 16. I have D to C, which is Y. Okay, and I also have A to C, which is X. And the A to C is X. And I have, what else? D to B is 12. So now I can set up my proportions. So since they're similar, I know the side ratios are all going to be the same. So I know the side ratios, okay, when I'm circling in red. So I know x over 4 is going to have the same side ratio as 16 over x. So I have x squared equals 2. So I have 16 times 4, which is 64. Therefore, x is equal to the square root of 64, which is 8. So that's x. So to solve for y, pick two triangles that contain y, and that's triangles 1 and 2. So I know here I have y and 12. So again, their side ratios are going to be the same. So the side ratio of y over 12 is going to be the same as 4 over y. So I have y squared equals 48. So y equals the square root of 48. So 48, the highest perfect square that goes into 48 is 16. So to simplify this, I have square root 16 and square root 3. Square root of 16 is 4. 4 square root 3 is my answer for y. Let's try another example. Solve for x and y. Well, first of all, you have to know that you have a right triangle and you have an altitude going to the hypotenuse of a right triangle. Therefore, you have three similar right triangles. So the first thing I'll do is label my original right triangle. So I have A, B, C, D. I'm going to redraw my three right triangles. They're all going to be similar. So all these right triangles will be similar, meaning that the angles will be correspondingly congruent and the side ratios will all be the same. Well, not all the same. The side ratios between any given two triangles will be the same. So here's my original triangle. Here's triangle 1. Here's triangle 2. Triangle 1, triangle 2. So in the original triangle, I have A, B, C. In triangle 1, I have angle D as my 90 degrees. Triangle 1 shares angle A with the original. So A goes up here and C. D is my 90-degree angle in triangle 2. B is the shared angle, so B has to be in the same spot as the original. And C. Now I can input my information. So I know that A to B is 9. I know that A to C is X. I know that D to C is Y. A to D is 4. A to C is X. D to B is 5. And C to B is unknown. I don't really need it. So now, in order to solve, I pick two triangles that contain the same variable. In this case, I'm going to pick the original triangle and the one triangle. They both have x, so I can solve for x. So I know that the side ratios between the original and triangle 1 will be the same. So I have x over 4 is going to be the same as 9 over x. So when I cross multiply and solve, I have x squared equals 36. X equals the square root of 36. So x is equal to 6. I can solve for y by picking two triangles that contain y, and that's triangle 1 and 2. Therefore, the side ratios between triangles 1 and 2 will also be congruent. So y gets compared to 5, and 4 gets compared to y. So I have y squared equals 20. Y equals square root 20. Highest perfect square that goes into 20 is 4, so square root 4 square root 5, so y is equal to 2 square root 5. And we're done. So again, the key to solving similar right triangle problems when you're given the altitude that goes to the hypotenuse is to draw your three right triangles, label them correctly, and then set up your side ratios using proportions. We'll do one last problem. I'm going to solve for x. Okay. So I know that they're similar right triangles. So I'll draw them. So here's triangle 1, here's triangle 2, triangle 1, triangle 2. Here's the original. So in the original, I have B as my 90-degree angle, and I have A and C. Triangle 1, I know D is my 90-degree angle. Triangle 1 shares C with the original, so C is up there. Triangle 2 has a 90-degree angle of vertex D. Triangle 2 shares angle A with the original, so A goes here, and B. Now I can input my information, so I know that B to A is 20. So B to A is 20. I know D to A is X. I know C to A is X plus 9. I know C to D is 9. Okay. So that's all I have for information. That's all for X. I picked the two triangles that contain X, original and triangle 2. Therefore, I know the side ratios between the original and triangle 2 will be the same. Why? Because I know that they're similar right triangles. So I know that X plus 9 gets compared to 20. So I know X plus 9 gets compared to 20. And I know that 20 gets compared to the X. So here I'm going to have to cross multiply. So I have X times X plus 9 equals 400. Distribute X squared plus 9X equals 400. It's a quadratic, so I'm going to set the equation equal to 0. So I have X squared plus 9X minus 400 equal to 0. How do I do that? I just subtract 400 from both sides. Now I'm going to use the quadratic formula. You can also factor this by finding two numbers that multiply up to negative 400 and add up to 9. But I'll do the quadratic formula. So remember that the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a when given ax squared plus bx plus c equal to 0. So in this case, a is 1, b is 9, c is negative 400. So I know x is equal to negative 9 plus or minus the square root. 9 squared is 81 minus 4 ac all over 2a. 2 times 1 is 2. So I now have x is equal to negative 9 plus or minus the square root of. So I have 4 times 400 is 1600. So I have 81 plus 1600. How did it turn to plus? Because again, a negative times a negative is a positive. All over 2. So I have x equals negative 9 plus or minus the square root of 1681 all over 2. So if I take the square root of 1681, I get 41. So x equals negative 9 plus or minus 41 over 2. So remember, you got to break it down to negative 9 plus 41 over 2, negative 9 minus 41 over 2. So if I do 41 minus 9, this is 32 over 2, which gives us 16. Negative 9 minus 41 is negative 50 over 2, which is negative 25. So x equals negative 25. x equals 16. But I only choose x equals 16 because that value will be the only value that makes my side lengths positive. So this is a good problem because it actually involves quadratics using the quadratic formula, or you can actually do factoring. So there we go. There's our lesson on similar right triangles. If you have any questions, please send me an email.